Hello, this is page 2 of the chapter 1 review. To start, we got to find the equation of a line passing through a point and perpendicular to another line passing through a couple other points. So, when I see that it's perpendicular, this leads me to think opposite reciprocal slope. Opposite meaning if it's positive, make it negative. If it's negative, make it positive. Reciprocal meaning flip it over. So let's figure out the slope of this line that passes through these 2 points. Well, we can use the slope formula, y2 minus y1 over x2 minus x1. Well, that gets me 6 over 3, or 2. So the slope of the line passing through those 2 points is 2. The perpendicular line is going to be negative 1/2. Opposite making it negative, reciprocal making 2 1/2. Now I've got my equation I've got the slope, and I've got a point. This makes me think about point-slope form. Y minus y1 equals m times x minus x1. Or in this case, y minus the y value is 5 equals the slope, negative 1/2, times x minus the x value, which is 4. Done. I could solve for y and write it into slope-intercept form, but if I need to find the equation, this is good enough. Let's move on to the second problem. F of x is 3x squared minus 5x plus 4. Well, find f of x plus h minus f of x all over h. F of x plus h to start, I'll take all of my x's and make them x plus h's. 3 times, not x squared, but x plus h squared. Minus 5 times, not x, but x plus h, all plus 4. Now minus f of x, which is, of course, 3x squared, minus 5x plus 4, all over h. Now, things have to get a little bit more expanded before they get simpler. Let's take x plus h squared and multiply it by 3. You'll get 3x squared plus 6xh plus 3h squared, minus, distributing that 5x minus 5h plus 4 minus 3x, if I distribute that negative to all the different terms, minus 3x squared plus 5x minus 4. And again, all of this is over h. So this looks huge now, but luckily the beauty of these problems is that so much of them cancel out every single time. For example, I see a plus 3x squared and a minus 3x squared. I see a minus 5x and a plus 5x. I see a plus 4 and a minus 4. All of that cancels out, leaving me with the simple 6xh plus 3h squared minus 5h all over h. I can factor out an h from the numerator, and I get h times 6x plus 3h minus 5 all over h. More things cancel. And after all of that, I'm left with 6x plus 3h minus 5. Pretty amazing that it goes from being so huge to so small. But in each problem, when it comes to this problem, every single time, you're going to figure that you can cancel out pretty much everything. So, if you haven't canceled stuff out by the end of this problem, you've probably done something wrong. Let's move on to problem number 6. I've got the graph of an equation, and I want to do some transformations. For example, this plus 1 is going to move the graph left 1. This negative 3. Well, the 3 is going to stretch by a factor of 3. The negative is going to flip, and since it's outside of the function, it's going to do it vertically, affecting the outputs. And the plus 4 is going to shift up 4. Now, a couple ways you can do this. I can take this entire graph, shift everything left 1 and graph that, then stretch it by 3, graph that, flip it vertically, graph that, and move it up 4. But instead, I think I'm going to just take each point, this point at negative 7, comma 0, and do the transformations to that. Well, from negative 7, 0, I shift left 1 to negative 8, 0, stretch it vertically, doesn't really change anything, flip it vertically, doesn't really change anything, and shift it up 4 units. It moves to here. Let's go to the next point, at 0, comma negative 2. Well, I start at 0, negative 2, I go left 1, stretch vertically by a factor of 3, getting me to negative 6, flip vertically, going to positive 6, and then shift up 4, putting me at positive 10. There's my second point. Third point is at 2, comma 0, so I shift left 1, stretch by 3, does nothing, flip vertically, does nothing, and just go up 4 units. Next point is at 6, comma 3. So I start at 6, 3, go left 1, stretch vertically by a factor of 3, brings me up to 6, 9. Flip it vertically at 6, negative 9. Was it 6? No, 5, negative 9, because I shifted left 1. And then shift it up 4 units, putting me at 5, negative 5. Last point is at 10, 0. So I will start at 10, 0, go left 1 to 9, stretch doesn't do anything, flip doesn't do anything, shift up 4. In the end, this graph will look like this. I can see that everything's moved over 1. Awesome. I can see everything's stretched out. It looks like it's flipped over, and it's moved up. A quick check to make sure that I've done things what seems to be right. Hope that you found this useful, and feel free to check out the others.